I'm Anil Kumar. Welcome to my series on vectors. Here are 5 questions which will help you to understand the concept of vectors when applied to geometric and algebraic vectors. Question number 1. Determine a unit vector using dot products that is perpendicular to both A 3 minus 2 7 and B 2 minus 1 2. So as mentioned here, you have to use the concept of dot products to find a unit vector perpendicular to both these vectors, right? Question number 2. Determine the angle to the nearest degree between vector A, which is 1 1 1, and vector B, which is square root 2 minus 1, square root 2 plus 1, and square root 2. Question number 3. The vectors A minus 5B and A minus B are perpendicular. If A and B are unit vectors, then determine the dot product between them. Right? So we are given this condition. These two vectors are perpendicular. You need to find A dot B. Question 4. Calculate the dot product for the two vectors shown in the diagram. Question 5. True or false? Justify your answer. If A dot B equals to 0, then A and B are, the vectors A and B are always perpendicular. B. A dot B dot C is scalar. So I'd like you to pause the video, answer these questions, and then look into my suggestions. Now you will notice that question number 1 is probably the toughest question in this, and question number 5 is the simplest of all to answer. So when you look into a test paper or a quiz like this, do not follow the pattern. You choose from where you should begin, right? So what I'm going to do here is I'm going to start from question number 5. That makes sense to me, right? Question number 5 is true or false. Justify your answer. First thing we are saying is A dot B equals to 0. It implies that vector A is perpendicular to vector B. Is it true or false? The answer here is, let me write it in red, false. Now many of my students will think why it is so. Well, there is a very important condition, right? Note, vector A or and vector B could be 0. Could be 0 vector. Even then, you'll get a dot product. Correct? So it is important to note that above condition is always true if and only if vector A is not equal to vector B and it is not equal to 0 vector. Right? So if one of them is 0, they may or may not be perpendicular. Who knows? But that condition is very important. And that is why this is a very important question to understand when you talk about dot products. Correct? So that is the answer for part A. Now let's look into part B. What do you think? A dot B dot C, it is a scalar quantity. Well, A dot B is a scalar quantity, but when you have a scalar and a vector, right, so these are all 3 vectors, it makes no sense. Why? Dot product is between 2 vectors. Correct? But A dot B will be scalar, right? So scalar dot, now you could have scalar multiples, perfect, but there is nothing called dot product between scalar and a vector. So that makes no sense. So this statement is also false, correct? So this statement is also false. So that is the very basic concept about dot products, right? Now let's take a question number 4. Calculate the dot product for the two vectors shown in the diagram. So that is how we geometrically represent our vectors, right? So we are saying vector A is along this direction and vector B is in some other direction, which makes an angle of 120 at this place, right? You need to find the dot product. I'd like you to pause the video, answer this question, and then look into my suggestions. So if I have vector A and vector B, and if I want to find dot product, that's magnitude of A times magnitude of B times cosine of angle between them. Now what is the angle between them? Now I've seen many times students will take 120 as the angle between them, and that's the whole idea. If you do that, you get it wrong. That is the angle between them. So when you're looking at the vectors, you have to place them tail to tail, right? So this is one vector. The other vector for you is this. Do you get the idea? So you have to think like this. This vector has a magnitude of 3, this vector has a magnitude of 4, and the angle between them is 120 taken away from 180, which is 60 degrees. Does it make sense to you? So cosine of theta is 60 degrees, and now you can find the dot product. So magnitude of A is given to you is 4, and then B is 3, and cos of 60 degrees, which you know is half, right? So it is 4 times 3 times half. Well, you will always make your special triangle to find this, or use calculator, right? So this is 60 degrees, 1, 2, and square root of 3, correct? So half of 4 is 2, 2 times 3 is 6, so the answer is 6. Does make sense to you, right? So that is another very important question. Now, if you know the concepts very clearly, these questions are not going to take more than a minute each. But if the concepts are not clear, you're not going to get the right answer. So place the vectors tail to tail and then find the dot product. Perfect. Here is question number 3. This is about vectors algebra. The vectors a minus 5b and a minus b, right? So we'll put dash on them. Vectors are perpendicular. That means a minus 5b dot a minus b should be equal to 0. If a and b are unit vectors, we are given that magnitude of a is equal to magnitude of b, and both are unit vectors. That is given to us. Then find what a dot b is. Well, let us expand this. So when you multiply, dot product, so you get a dot a minus a dot b, right? And that gives you minus 5 b dot a, and this is plus 5 b dot b, right? Equals to 0. Now a dot a is magnitude of a square. A dot b we need to find, so let's just keep it like this, right? Minus, this could be written as 5 a dot b. It's a scalar quantity. A dot b is equal to b dot a. And here b dot b is magnitude of 5b square. So what we get here is 1, and this is minus 6 a dot b. And here we get plus 5 equals to 0. So we can take this on the other side, and we say 6 equals to 6 a dot b, and that means 6 over 6, which is equal to 1, is vector a dot b, right? So we get our answer that a dot b is equal to 1. Is that clear? So that is how you should be doing that algebra part of vectors. So in 3 different questions, we have understood the basic concepts. That was the communication question. Second was based on how the vectors could be geometrically placed. And question number 3 here is how we do algebra with vectors, right? Question number 2. Determine the angle to the nearest degree between vectors A and B, right? So these are two vectors. So we'll use the formula straight away. So if I have A dot B, I could always write this as magnitude of A times magnitude of B times cos of theta. So whenever we want to find the angle, so we say cos theta equals to the dot product divided by product of their magnitudes, right? So let us find out what is the dot product between the two vectors, right? So let's say what is A dot B. Let's calculate them separately. So A dot B is 1, 1, 1 dot square root of 2 minus 1 square root of 2 plus 1 square root 2, right? So that gives you square root of 2 minus 1 plus square root of 2 plus 1 plus square root of 2. So plus 1 and minus 1 cancel, and what you get is 3 square root of 2. So that is their dot product, right? So this is, we have A dot B as 3 square root 2. Let's find their magnitudes, right? So magnitude of vector A is square root of 1 square plus 1 square plus 1 square, which is square root of 3. And magnitude of vector B is, we have to square each one of them. So we have square root of 2 minus 1 whole square plus square root of 2 plus 1 whole square plus square root of 2 whole square, correct? Now this part is slightly tricky. So when you expand this, we get 2 minus 2 times square root 2 plus 1. And here when you expand, you get again 2 plus 2 square root 2 plus 1, and this gives you 2, right? So that is all you get within the square root. And as you can see, the terms 2 square root 2, 2 square root 2 cancel, right? So, well, here there's plus, right? Okay, so these cancel. So what remains here is 2 plus 1, 3, 4, 5, 6, 7, 8. So this is, the magnitude of P is equal to square root of 8, clear? Right, so just add them carefully. So it is 2 plus 1, 3, 4, 5, 6, 7, 8, right? Sometimes you may forget one of the terms and you may get a wrong answer. So we got all the components. Now I'll again write down what cos theta is equal to. A dot B we got at square root of 3 times square root of 2, right? So that is 3 times square root of 2. Then magnitude of A, we got square root 3, and magnitude of B is square root of 8, right? So divided by magnitude of A, which is square root of 3, times magnitude of B, which is square root of 8. Is that clear to you, right? That is what we have. So we could actually rewrite this as 3 over. So within square root, we could cancel these, right, with 4, right? So when you cancel this, it is actually 4 square root 2, right? So we get here 2 square root 3. Is that clear to you? Let me go one more step. I'll write 3 square root 2 in the numerator, and in the denominator, I'll write this square root 8 as 4 times 2. So I could write this as 2 square root 2, and we have square root 3. Is that clear to you? So this square root 2 cancel. So what we get here is square root 3 over 2 square root 3, right? So that's what we get. So theta is equals to cos inverse of, if you want, you can also write this as square root 3 over 2, right? So that is what you get as, you could also write this as square root 3 over 2. Now from your special triangles, actually you know what this theta angle is, right? So if you use 30, 60, 90 special triangle, in that case, you know the sides. Cos of 30 is square root 3 over 2. So theta equals to 30 degrees. Is that clear? So the answer for this is that the angle between them is theta, which is equal to 30 degrees. Is that clear? That is how we are going to answer this question. Perfect. Now that brings us to the very first question, which is one of the toughest questions in this group. Let's see how to answer it. The question here is, determine a unit vector using dot products that is perpendicular to both A, which is vector A, which is 3 minus 2, 7, and vector B, which is 2 minus 1, 2. You can always pause the video, answer this question, and then look into my suggestions. Now let us say that C is a vector perpendicular to both vector A and vector B. In that case, we know that, let's say vector C is x, y, z, right? So in that case, vector A dot vector C should be equal to 0. And also, if I say C is x, y, z, and A is 3 minus 2, 7, let me write down C equals to, let's say, x, y, z. We don't know what it is. Let me insert this here. Okay. So that is the vector C. So that really means that A dot C is 0. That is to say, 3 minus 2, 7 dot x, y, z equals to 0. So when you do the dot product, you get 3x minus 2y plus 7z equals to 0. Now that also means that B dot C is also equal to 0. So that means 2 minus 1, 2 dot x, y, z equals to 0, or 2x minus y plus 2z equals to 0. So we actually get two equations from here, and we have three things to figure out. So that means we are looking for a parametric solution. So what we could do here is that we can times this equation by 2 so that we get 2y, 2y, and then we can get rid of at least y, right? So if I times this by 2, I get 4x minus 2y plus 4z equals to 0, right? So let me call this as our equation number 3. And now, if I do equation 3 minus equation 1, what do I get? So from 3, I am taking away equation 1, right? So we get 4 minus 3 as x, minus 2y is 0, and this minus that gives me minus 3z equals to 0. That is to say that x is equals to 3 times z. Correct? So now we can actually define a parameter and find what x and z could be, right? So let's take z as equal to, let's say, t. Let's say, so let's let z be some parameter t. In that case, x will be 3 times t, right? So if I put this value in one of our equations, let it be equation number 2. So equation number 2 is, okay, we'll call this as equation number 4, right? So in 2 sub 4 in 2. Okay, that is these two values. Okay, so 2 is 2x, so we'll write 2 times x is 3t, right? Minus y, we don't know what y is, plus 2 times z, and z is t for us. That should be equal to 0. So from here, we can find that 6t plus 2t is basically equal to y, and that implies y is equal to 6 plus 2, 8t. Is that clear to you? So we get the value of y. So that means the vector c for us could be, in terms of our parameter t, it could be written as x is 3z, 3t, y is 8t, and z is t. So that becomes our vector which is perpendicular to both, right? T could be any real numbers, right? Where t belongs to real numbers. any real number. In this particular question, we are more interested in finding a unit vector that is specific. That means I have to divide this by its magnitude, right? So what is going to be the magnitude? Well, the magnitude will be, we'll do square root. Let's find the magnitude of this C. So that is equal to 9t square plus 864t square plus t square, right? So we'll do squares of them and add it up. So 9 plus 10 and then plus 1 is 10. 64 plus 10 is 74 t square square root, right? So that becomes the magnitude for us, right? Which is basically t, which could be written as t square root 74. 74. I'm not really simplifying on this, but that gives me the unit vector. So the unit vector C, which I'm writing like this is for unit vector, is basically you have to divide this vector by this term. So what you get here is 3 over square root of 74, 8 over square root of 74, and 1 over square root of 74, right? T and T cancels. So that becomes the unit vector, which is going to be perpendicular to both the vectors. And that is how you could do this using scalar products, dot products. Do you get the idea, right? Now in the next unit, we'll learn about cross product, right? So alternate solution is to use cross product, which we are going to learn in the next unit, right? So for now, I think that should be good enough. Feel free to write your comments, share your views. I hope you like the selection of these questions. They really give you insight to dot products. So as we move on, we'll take more questions related to application of dot products, especially for work done and similar examples, and hope you find it very interesting and useful. Please feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for watching and all the best.